Have you ever wondered how much storage capacity does our brain have? In terms of a phone memory card, a USB drive, or even a server on a social media platform? Many sources claim our brains can store an entire library. Is that true? In this video, we will explore the storage capacity of the brain. First, is there a way to calculate the brain's capacity? Basically, the brain is not a memory card, nor any storage device, so it cannot be measured or calculated precisely. However, we still have a few ways to estimate the brain's storage capacity. So, how do we do that? How do we estimate it? And what is brain capacity? We will explore two extremely interesting methods. First, calculating brain capacity through the brain's hardware. That's the number of neurons and their connectivity. Experts at the Institute of Biological Research in California, USA, have stated that our brains contain up to 1 quadrillion neurons. They have also conducted numerous experiments and calculated that each synapse can store information equivalent to 4.7 bytes of electronic data. Thus, a quadrillion synapses can store up to 4.7 quadrillion bits of information, or roughly equivalent to about 4.3 exabytes of data. Although it was previously believed that each of us only uses less than 10% of our brain, this information is completely wrong and has been specifically studied. Through this, scientists have shown that although the brain is composed of many different functional components, when it is active, all those parts are active, not just 10%. However, out of a quadrillion neurons, only half are used for storage, so the actual capacity of the brain is only a little over 2 exabytes. This seems like a small number, but let's try converting it to memory cards and computer hard drives. An exabyte would be equivalent to 4,500,000 gigabyte hard drives, or 100,000 of the world's largest 20 terabyte hard drives. If an ebook has a size of 10 megabytes, then our brain would be the world's largest library with 40 billion books. The world's largest library today is the Library of Congress, with over 32 million books and an area of 30,000 square meters. So, if we could buy a library and store all of our brain's 40 billion books, it would require 1,250 of those libraries in the US, or a floor area of 37 million square meters. It would be wonderful if that huge library had a transportation system to make it easier to find books. That sounds daunting for the brain's memory, but it seems we can't possibly remember all this data. And this approach seems to yield rather unrealistic results. So we'll move on to the second calculation. This calculation is based on human reality. As you know, not many people live to be 100 years old and still have a sharp mind. But let's just assume each person lives to be 100 years old and still has a good memory of the past. Subtracting the first 3 years of life, when memory is almost non-existent, leaves only 97 years of active memory. Our lives are like a film, and when we recall the past, we rewind that film. Therefore, to calculate memory capacity, we need to calculate the capacity of this film over 97 years. But the video file size will depend on the following factors. First, the quality of the frame. Studies suggest that the human eye, when looking at a scene, has a resolution of 576 megapixels. But that includes AI for image stitching. When focusing on one spot, we only see about 7 megapixels. And a 7 megapixel image usually has a file size of about 2 megabytes. So we have the frame size. But how many frames per second, FPS, is a segment of a lifetime? Many experiments have shown that when driving for 10 minutes, you only remember about 10 new images when you get home. That means one frame is recorded every 60 seconds. But why is the video so smooth when you recall it? That's because our brains are very intelligent. They only need to take a few images and imagine them as a movie. For example, if you see a car going from point A to point B in about 60 seconds, your brain actually only remembers the image of the car. When you recall it, it automatically creates the image of the moving car in your head. So, life is only 97 years. Each year has 365 days. Each day has 24 hours, minus 8 hours for sleep, leaving 16 hours of waking time. Each hour has 60 minutes, and each minute corresponds to a frame of 2 megabytes. So the total storage capacity of the movie in the brain would be 97 pi 365 pi 16 pi 60 pi 2 equals 68 million megabytes, or 65 terabytes. This is significantly less than the 20,000 terabytes obtained using the first method. Furthermore, a study also showed that if an image is recorded 21 times before it is permanently stored, this means the brain doesn't store the image immediately upon seeing it. It only stores it after at least 21 repetitions. Therefore, we have to divide by 21. 65 divided by 21 equals approximately 3.1. So, Our brain has a maximum capacity of 3.1 terabytes, or 3,100 gigabytes, not including the data that is lost even after 21 repetitions. 3,100 gigabytes isn't a huge number, but if you convert it to images, that's 1,500,000 frames, a massive amount. With that many frames, it's impossible to create an incredibly rich memory. You might wonder why the brain also stores sound. In fact, sound is also a form of image combined with logic. For example, when someone says they'll give you $1,000, you'll remember that statement, and based on the image of the bills combined with analysis, you'll consider, how big is $1,000? What can it buy or change? So, sound is actually an image inside the brain. Hopefully, science will have a more accurate way to calculate the capacity of the brain in the future. What do you think the capacity of our brain is? Please leave your comments. Thank you for watching the video. Goodbye, and see you in the next video.